This lecture is the first in the series of lectures on Bezier curves, which are used for a type of curve fitting. We can generate the formula for Bezier curves using parametrizations of lines. For this series of lectures, we will use what one can refer to as the standard parametrization of a line. We take 2 points A and B and examine the line segment determined by the 2 points. Take a generic point P sub 1 that lies on this line segment. We will generate a parametrization for the coordinates of P sub 1. By parametrization, we mean that x sub P sub 1 and y sub P sub 1 will be functions of a parameter t. Take the vector that starts at A and ends at B, and we'll compare this to the vector A P sub 1. Because the two vectors point in the same direction, we can write the vector A P sub 1 as a scalar multiple of the vector A B, which means that we can find a scalar t such that the vector A P sub 1 is equal to t times A B. We will illustrate what this equation means by first taking a look at the t values between 0 and 1. The length of the vector A P sub 1 divided by the length of the vector A B is equal to t, so that if we were to push t down to 0, the length of A P sub 1 is also equal to 0. And not only that, observe that when t is equal to 0, A and P sub 1 are exactly the same point. As t increases, P sub 1 moves along the segment towards B, so that when t is equal to 1, P sub 1 and B are exactly the same point. By pushing the value of t beyond the value 1, we are able to get all the points beyond B. On the other hand, the negative values of t generate the points on the other side of A from B. Writing out A P sub 1 in vector form, we simply take the difference between the coordinates of the points A and P sub 1. The vector A P sub 1 is equal to x sub P sub 1 minus x sub A for the first component, and y sub P sub 1 minus y sub A for the second component. The components of AB are made up of the differences between the coordinates of B and A. And so we obtain the component form of this equation, which is this vector equation. We isolate x sub P sub 1 and y sub P sub 1 to get this vector equation. This vector corresponds to P sub 1, this vector corresponds to A, and this one to B minus A. And so we write P sub 1 as equal to A plus t times the quantity B minus A. Or using the equivalent form, P sub 1 is equal to the quantity 1 minus t times A plus t times B.